So today we are going to do a webinar around introduction to biometrics. We'll talk a little bit about what biometrics are, where we use them, some of the benefits of certain biometrics, and some of the things you need to be concerned about with specific biometrics. This is not a complete course in biometrics, but merely an introduction to biometrics. So let's start right at the beginning with the definition of the word biometrics. So the word biometrics is derived from two words, Greek word bio, meaning life, and metric, meaning to measure. So it really is around measuring life. Now, that is quite important. We're not looking at forensics. We're looking at measuring live human bodies. Typically, when I meet you in the street, if I know you, I might recognize your face, or the way you walk, or the way you talk, or the way you behave. All of those are biometrics. So it's involving the application of statistical analysis to biological data. I'm recognizing you by the way you look or behave. Now, what we're trying to do here is automate this. You know, it's no good if I remember I saw you somewhere, but I'm not sure where. I'll come back to you. That's not good enough. What we're looking is the biometrics we're talking about is automated biometrics, measuring life, doing statistical analysis on biological data to actually be able to identify a person. So typically the human characteristics that we can measure, and there are many more, this is not a complete list, are things like fingerprints, veins, face recognition, DNA, handwriting. So you'll see from this list, some are really easy to measure, some are extremely difficult to measure, some are reliable, some are extremely unreliable. You know, things like odor or scent of a person can easily be masked. The voice can easily be altered. So some of these biometrics are actually easy to measure. Some are very difficult to measure. Some are very accurate, like DNA, for example. Some are less accurate, but all of these are human characteristics that we can measure. And we can really break them down to physiological and behavioral type activities. So behavioral would be things like keystrokes, signatures, how I sign. And even then, if we look at signing, if I'm signing at a bank, for example, or I'm signing access into a club at 2 o'clock in the morning, my signature is likely to be very different. So it really is, you can see you need to look at each of these biometrics, both the behavioral biometrics and the physiological biometrics, and see which one has the right accuracy for whatever task you want the biometric to perform, where you would like to use the biometric. What's also quite important is looking at where these biometrics will be accepted in a court of law as identity. So we typically know signature, as identity, face, DNA, fingerprint. Those are really well established in a court of law if there is ever an issue with identifying a person. You know, you signed a document that is regarded as binding. If someone recognizes you in a lineup, again, that would be measurable in a court of law. So it is important when you look at where you're going to be using these biometrics to understand the security levels that you'd need with each of these biometrics. So one of the things that is quite important, and the slide's actually maybe in the wrong place, but more and more we're seeing a move to multimodal biometrics. On the previous slide I showed you the different biometrics. Some are very easy to measure, some are more difficult to measure. Often by putting more than one biometric together, you can improve the recognition rate and the reliability. And the other thing that's quite important is different biometric modalities might be more appropriate for different kind of applications. So if these biometrics are statistically independent, then you can increase the recognition rate and the reliability of biometrics dramatically by using more than one. And you see that, for example, on Ideco's BIMS device, where we have a variety of multimodal biometrics that we can use as part of a process. So if you look at biometrics in general, certain criteria are needed from biometrics in order for it to be used as a good identification measure. So some of them are, it needs to be universal. Each person must possess the same biometric characteristic. It's no good if some people have this biometric, other people don't. It makes it really difficult to measure. So it must be universal. The other one, it needs to be unique. We can't have two people sharing the same biometric, say hair color, for example. It's not unique enough for us to actually use it to identify a human. It needs to be permanent. So, for example, if you look at fingerprints from about the age of 16 years, it's very stable. So that what makes it great. But if you're measuring biometrics in the younger people, then you need to look at other types of biometrics. It needs to be measurable, so it must be easily collectible, the biometric. Otherwise, it's fairly useless. Uh, um, the benefits of biometrics is they can't be lost, they can't be stolen, they can't be forgotten, and they can't be shared. Um, so those are real benefits of biometrics. It's really difficult to forget your fingerprint or to have your fingerprint stolen. Biometrics have that capability, that the benefit that they can't be lost, stolen, forgotten, or shared. If you look at the enhanced security you get from biometrics, is you can't, as we term buddy clock, people come in behind you through a gate, for example, if you're measuring biometrics. And the technology is a huge deterrent if you're looking at biometrics appropriately, or the appropriate biometrics for whatever use you wanted. If you look at administration, we're reducing administration costs dramatically, because if you're looking at things like replacing access cards, a process to give out a new card, time saving with temporary cards. So there's a reduced administrative feature by using biometrics, and also greater convenience for you and for your employee. Imagine if every time you got to work you had to phone security for them to come unlock a door for you. It would be extremely inconvenient. Now just use a fingerprint or facial or some kind of scan, and I can get into the building. People don't forget. You don't have to worry about forgetting cards or pins if you're using biometric. Um, and you don't have to worry about tracking where these cards are. So there's huge benefits of using biometrics in general. Now, the history of biometrics really goes back to the 14th century, where we saw the Chinese starting to look at measurements and behaviors of people to be able to identify people. We have seals with fingerprints on the seals. So really, biometrics is not new. There are cave paintings of people's attributes, faces, etc., which are really biometrics that we use today. So biometrics goes way back, but we're really starting to see a strong focus around about the 14th century. In the 19th century, you saw the French police really start focusing on body measurements, photographs from identification perspective. And then you saw the emergence in the 20th century of the fingerprint technology, which is really standard today for most biometric environments. So you saw that in the 20th century, not just in England, but also in the US, when they started looking at patterns within fingerprints. So let's look at the various type of biometrics that we can use as part of the processes we define. So the first one I'm going to talk about is facial recognition. So facial recognition really is has huge advantages, because you can use current cameras, video cameras or thermal imaging that often is there already within organizations. And typically what you're doing is you're looking at the analysis of the shape, the pattern, and the positioning of facial features. So it's things like the distance between eyes and nose, the shape of the mouth, the location of lips on the face. What we're seeing, for example, is with Otimorpho, is that's emerging not just to 2D facial recognition, but even to 3D facial recognition. So as you turn your face, looking at the entire spectrum of what your face looks like. And that's basically what facial recognition does. It's really looking at the structure of the face. There are some huge advantages and some disadvantages. If you look at some of the advantages, obviously there's no contact. It's very intuitive. It's hands-free. I can be carrying something when I walk into a building, look at a camera, and it can recognize me. And facial is really great if you're looking at bimodal, if you're looking at more than one mode, because it's something that's very intuitive. The sensors currently are in most buildings already, the cameras. There are some negatives, unfortunately. It's very sensitive to lighting, to expression. It does change as I age. It also changes as I put on weight or lose weight. Um, and if I'm wearing a hat, I grow a beard, wear glasses, it does affect the system. And you can see systems slow down dramatically if I'm wearing, for example, a hat and I grow a beard or wear glasses. So there are some negatives in terms of facial recognition. But as I mentioned, it's quite a good environment if you're using multimodal, because it's very intuitive. It's not something you have to train somebody how to use to look at a camera. It's something that people are very familiar with. If you look at iris and retina, these are really good biometrics that are used in the industry today. What you're looking at with retina is the blood vessels at the back of the eye. What you're looking at iris is the physical iris, the ring around the pupil of the eye. As the iris expands or contracts to open the pupil to let more light in, what you see that there's tissue differences and vascular differences in the eye because of this contraction, to an expansion to let more light in. So you can see a lot of stripes and pits and furrows in the iris, which makes it a really, really good biometric. So both the iris and retina are really good biometrics they can use. As with all biometrics, there are some advantages and disadvantages. Typically, we protect our eyes really well, so it's less prone to injury. It's far more sophisticated. It's a very high level of security. It's very difficult to cover your eye or change your eye. But having said that, you now get lenses that you can put over your eye, which makes it quite difficult to recognize the iris itself. But there's no physical contact, and it's highly stable over your lifetime. As I said on the right-hand side, if you look at some of the negatives, it's very difficult to use with glasses because it is obstructed by glasses. It can also be obstructed if you're using certain contact lenses, colored contact lenses, for example. It can be affected by light, and typically it's a more difficult biometric to use. A lot of the iris technology, you have to be fairly close to the device. And for example, I have a situation, if I take my glasses off, it's very difficult for me to see anything. So take my glasses off and then line up to be able to read or position my eye in front of an iris reader sometimes can be quite difficult. So there are pros and cons to iris as well. And as we go through this, what's really important is you need to look at the application that you're going to be using this biometric for. So if you look at voice recognition, again, human voices are different because of the position and the shape and the movement of the jaw, the tongue, the larynx. So you can see huge behavioral movements as well as physical movements. The shape of my mouth, for example, can change that speaking pattern dramatically. So quite a useful biometric in call centers, for example, because it's something that I can just use a phone to identify. So something that I'm quite familiar with. Again, with all of these biometrics, there are some positives and negatives. Some of the positives, it's really highly acceptable. It's really easy to use. People know how to use their voices. You don't need to train them. There's no contact. And typically you're using a phone or a microphone, so it's relatively inexpensive. So the negatives, obviously, is that there's fairly low accuracy at times. It can be really badly affected by noises, other noises around you. And often, if you've got a very, very large database, a couple of thousand people, even 100 people in a building, there's not enough difference between all the voices to be able to use in a very large database. But again, as I mentioned right at the beginning, if you're looking at a multimodal environment, again, this is quite a useful modality that you can use from a biometric perspective. The next one we're going to look at is hand geometry. Now, this is not looking at the physical fingerprints anymore. You're not looking at the veins within the hand. What you're looking at is things like the length of the finger, the width of the finger, and the shape of the hand. So what you're looking at is kind of a three-dimensional image that a camera would read of your hand. Typically, you find this in access control. It's not the most reliable. You can see it's easy to use. There's a small template size. They're not that big of variances within a person's hand. It's very easy to capture, and you can handle a large amount of users. But it is a fairly low accuracy environment. The systems are typically more expensive than fingerprint readers. If you're missing digits or very large or very small hands, it becomes more difficult to read. And typically, you need a fair amount of space because you're positioning your entire hand, mostly with the fingers open, from a hand geometry perspective. So, again, a modality that you can use from a biometric perspective. The next one we're going to look at is palm and vein recognition. And typically what we're looking at here is the vascular structure within this, underneath the skin surface. Now, you can use this in conjunction with fingerprint, or you can use it on its own. So, for example, you get finger vein, but you also get palm vein. So, recognizing the vascular structure within the palm of the hand, or using it on a finger environment. So, there are different methods for the vein recognition. It's typically pushing light through the skin or reflecting light against the skin. So if you look at the light transmission method, which you see on the left-hand side, typically you're placing your finger between the image sensor and a light source. And infrared light passes through the finger when it's captured by the sensor. And that actually gives a very high level of contrast because light travels through the finger and then there's no effect of reflection. Again, because this has to pass through the entire body, only certain body parts are appropriate to use this kind of technology. If you look at light reflective, what you're doing is reflecting light from the same side of the finger as where the sensor is. So, there are issues there in terms of it can be a more compact environment that you project in the light and reading it from. If you look at the benefits and the negatives, it's difficult to forge. You're looking at the structure within the hand, the vascular structure within the hand. You confuse it easily with other biometrics. So, for example, if you're doing the fingerprint and you want vascular structure in the finger as well, it's easy to do it quickly together. And again, Otimorpho have a range of products that do that. It's high-level security. The negative, obviously, is it is affected by cold and heat, can affect that transmission of light. There are often hygiene concerns, and I've seen situations where certain medical conditions can actually affect the recognition from a blood perspective or from a vascular structure. If you look at fingerprint recognition, which is still one of the most widely accepted biometrics, typically, if you look at your finger, you'll see there's different landmark points known as minutiae where the ridges end. You can see a variety of ridge endings. I've got some pictures on the right-hand side. And that collection of those fingerprints is what we then use to identify fingers in the environment. So the minutiae are those ridge endings. You can see typically we have about 80 to 95 minutiae per fingerprint. Typically, if you look at people, there's no more than 8 common minutiae points within the fingerprint environment. And you can see what the courts in the US and South Africa use. And again, the OT Morpho, matches a very high level of minutiae points within the fingerprint environment. So it is the most commonly used biometric technology. Lots of research. I mean, you saw we talk about from the 20th century upwards. Most governments and police services use it today. The fingerprint sensors are really small. It's easy to operate. And you've got multiple fingers you can use. So again, on our BIMS device, we capture all 10 fingers, but there are multiple fingers you can use. It's not like you're looking at an eye, for example, where there's only one or two. The negative is obviously there's this hygiene perception, and fingerprints are affected by age, as you saw earlier on, until you hit your early teens. They're not fully formed, and if you're doing a lot of manual labor in the field or mining, or laying bricks where you're using abrasives the whole day, those fingerprints can actually be rubbed off and are very difficult to capture at that point in time. So advantages and disadvantages to that as well. So one of the things that's important when we look at biometrics is the enrollment process. So, it's a situation of garbage in, garbage out. If you don't enroll properly, you're not going to be able to recognize that biometric later on. So enrollment is really important. One of the questions that I often get asked is, if I use a fingerprint, for example, and I present a fingerprint, can someone make a copy of those fingerprints? Typically, what we do is we're not matching the fingerprint. We're actually creating a template of the fingerprint. So what we do is we present the biometric, we capture the biometric, we extract the features we want, we create a template, we typically encrypt the template, and then we store it. So what we comparing is the template, not the physical picture of the fingerprint. And the same applies to all the biometrics that we've spoken about today. But one of the key elements within biometrics is the importance of enrolling properly. One of the other things you see, and I'm going to jump a slide forward and then back to the slide, is the difference between identification and verification when we're using biometrics. So when we're looking at identification, typically what we're looking is identifying me against a whole database of templates. So I present my fingerprint or my voice or my face or whatever biometric I'm using, that is converted into a template, and then that template is compared to a whole range of other people's templates that are in the database. If you look at verification, it's quite different. With verification, I may be presenting a card. Maybe my fingerprint or other biometric is on the card. So I put the card against the machine, reads the biometric, and then wants me to present that biometric to that machine just to check that I am who I say I am. So that my fingerprint actually matches the one on the card, and it's not somebody that's using my card. So on verification, if someone takes my card, presents it to a machine, and then puts their fingerprint, obviously it won't work. All right. Now, why these are important is because if you look at most biometric devices, the hardware devices, they have database sizes that differ from verification to identification. So it's really important to understand the difference. In identification, we are looking or searching a sample against a database of templates. In verification, we're just comparing it to one. So as we look at a variety of biometric types, whether you're looking at finger, hand geometry, voice, retina, iris, you can see there are different levels of user acceptance, different levels of ease of use, different levels of accuracy. This is not a complete list, for example, of biometrics. We haven't included here palm vein, which is a Fujitsu technology, which has very high levels of accuracy, easy to use, and fairly high user acceptance. But you can see some biometrics typically people want to steer away from. Other biometrics people engage with quite readily. So it is quite important when you look at what solution you're trying to put together, look at a chart similar to this to decide which biometrics you should pair together for your specific solution. Something else that I want to measure, I want to talk about, which is quite important, which is false acceptance rate and false rejection rate, which is important when you look at the various biometric devices. So false acceptance is when the system says, "Oh, I know who you are," and they incorrect. So where I present a fingerprint, for example, and it says, um, "I recognize you. You can come into the building," but in fact, I'm not the person. I'm not the correct person. It's allowed me in, and I'm not a genuine user. Right, so that's quite important to understand the false acceptance rate. The false rejection rate is when I am a valid user, I come present my fingerprint, and it says, "I'm terribly sorry, I don't know who you are, therefore you can't come into the building." Now, both of these are important, again, looking at the application, because they determine which biometric you would use, for example. So here's a Fujitsu slide where they show the false acceptance rate and rejection rate across the various biometrics. And you can see typically fingerprint, finger vein, iris retina, palm vein is on the very high end of precision. Some of them have low practicality or medium practicality, but this is a good reflection of where you can use in terms of the security and the precision for the various biometrics modalities. So I just want to thank you today again for attending our webinar today. These webinars are recorded. If you wish to get a copy of this webinar, please don't hesitate to give Anna a call or drop her an email at anna@ideco.co.za. And until next week, have a good spring day. Thank you very much. Bye.